So the way we're going to structure this future of Linux discussion, the first part we're going to talk about is containers and clouds, kind of like where some parts, some initiatives within Linux are headed. And then we'll open up for discussion ostensibly around System D, but the gentleman who is going to be leading the System D part may come through the door at the last second. Otherwise, Howard is former InBug president, and he will ensure that we have a very thorough and fair conversation about System D.
It sucks!
Yeah. All right, so thank you all so much for your patience, and I think we're ready to get started. So, who am I? Wesley Duffy Braun, Twitter @WPhotos, and I'm a photographer, I'm a woodworker, and then during the day, I'm a software engineer at Red Hat. Yeah. But I am up here as a long-time 20-year Linux user, not as a Red Hatter. So on camera and everything, I'm just here as another open source person, not a Red Hat.
Would you say that your views represent Red Hat?
No!
Oh, okay.
And I interrupt for just a second, Wes. Regarding the open source comment, Tillman knows this one. Our dear friend Allison Smith got an award from your fine company, by the way. And she mentioned it to her colleagues, and the guy says, "You got an award for open source?"
Wow. So, what was I going to say? Something about, I have no idea if my views represent Red Hat. I'm sure in the other 7,000+ whatevers that are out there, there's somebody else who agrees, and then plenty who disagree with whatever I'm about to say. All right, so who here is familiar with Linux? Raise hands. All right, so this is a majority of folks are familiar with it. So we'll do a very quick thing. We don't have to talk about all these goodies about it, but the thing to remember with Linux it is an operating system. Strictly speaking, it is the kernel, although I haven't heard anyone reference GNU Linux in a while. It is, there are utilities, and then there's the kernel. Often it's just referenced, you just say Linux. Based on Unix, originally Linus Torvalds, founder of Linux, put a post out on the Minix, I think it was, CompOS Minix thread in August of '91, saying he was working on a semi-similar clone, but he was like, I'm sure it's never going to go anywhere. It'll probably never run on anything except 386 machines. The conversation picked up steam. First GPL release was in December of '92. Who knows what the GPL is? Everybody familiar with open source? Okay, great. So, and then just now, latest kernel posted earlier, I guess now, 2 weeks ago, 4.3. So some 24 years on, it is going very strong. It went from just one little box to being a server, generally speaking, server operating system. Some people were running it on their desktop, and now it's everywhere. Your phones, networks, your wireless cards, pretty much you could grab 5 dozen things in this room that are running some variant of Linux or embedded Linux or something along those lines. So when we talk about the future of Linux, it's like saying, well, where is the human, what are humans working on, right? It's like everything. So, where's Linux headed? Everywhere. It is growing, more people are adopting it. There are forks of it all the time. Forks, being, if you're not familiar, is when a code base, there's the original code base and then people branch off with it. There are companies that are utilizing Linux. There are agreements between not get along with each other folks utilizing Linux and open source philosophy. It's hard to separate in a way, Linux from open source. But when we talk about where Linux is headed, it's kind of going everywhere. So what I was thinking about with this part of it is to say, where are people using it in the future, right? So there are folks that are going to use it or are working on using it for very big workloads, and then there are folks who are working on using it for very small workloads. And those very big workloads are being found in the cloud, right? And we'll talk about what the cloud is in context of this conversation momentarily. And then very small workloads are with containers. And what that means as well, because that's kind of an overloaded term that has now kind of settled into a kind of a consistent definition. So what is the cloud? There is a definition of the cloud, and it says that the cloud is a model for enabling ubiquitous, convenient, on-demand network access to a shared pool of configurable computing resources that can be rapidly provisioned and released with minimal management effort or service provider interaction. It's distributed computing. It's pretty much anything could be squeezed into that definition. I think in a way, almost anything, right? But the important part of this is that it does not have to be somewhere else, right? The idea that if you are doing cloud workloads, big workloads, that they have to be in some far off place that you can never touch is not, for purposes of this conversation anyway, what I mean here. There are public clouds and private clouds and hybrid clouds, and though that's a whole other conversation. The idea when we're talking about undercloud. The idea is that with cloud computing that you can have these 5 characteristics. And this is where people are I think that this is not just where Linux is going, but I think the idea is that many companies' workloads are headed in this direction, and they're leveraging Linux and open source technology to enable this, these characteristics in their environments. On-demand self-service, broad network access, meaning that you can access a resource from your phone as well as a system that is at your house, as well as something that's in your in an actual data center. Right? You don't have to be physically located in one specific place to do that. Now, you may have to authenticate or set up VPNs, certificate exchanges, but you don't have to be sitting at one place to be able to access one specific network. Resource pooling, that you can take multiple systems and they will appear to the consumer like one resource. So if you have a whole bunch of CPUs, the consumer won't necessarily know that or even care. It will just say, here's my computation abilities. Rapid elasticity, so you can scale up if you are having people upload a whole bunch of photos, and all of a sudden you need 2 terabytes more space. The people uploading the photos won't see that. It will just be automatically provisioned. And then measured service, so folks can know how much is being consumed, both on the consumer side and on the administrative side. Stop if there's any questions, concerns, disagreements with any of this information here. So cloud computing categories, we've all been using them for a while, I think, especially the software as a service. Gmail and Tumblr, for example. Anybody use Salesforce or anything related to that? Yeah, software as a service, right? Then there's platform as a service, where you can develop on a platform that someone else has for you, but you don't have to actually worry about doing the maintenance of that platform, right? You just say, like, I want
Lamps.
a PHP environment. I'm sorry?
Lamp.
Well, to an extent, it would be the A&P side of that. Yeah. But the infrastructure as a service would be the LAMP stack. Yeah.
You're really talking about how much of the stack you're managing yourself versus you're paying somebody else to. So
Yes.
for most users, all we really care about is the application layer. Everything else that you do with the computer is to give you a stable platform for the application layer.
Right.
So, you can get, platform as a service or software as a service just to focus all of your energy on your program, your app, the thing that makes your company different from everybody else, and pay somebody else to manage the servers to keep everything up to date.
Yeah. Absolutely. So the thing I should have said at the beginning is that, or at one of the slides further back with the very big and very small workloads, is that not either of these, cloud or containers, are exclusive to each other, nor are they one better than the other. A lot of companies will see a feature set of cloud computing, for instance, as, oh, this is what we need. Then other ones will be like, oh, containers, that's all we need, just containers. We just want to give everybody containers. We'll get to that momentarily. So one thing I wanted to pass along is how to do cloud computing for yourself. Who's heard of OpenStack? Who's used OpenStack? Yeah? Great. No, raise it high, man. There it is. Well, everybody's just a little bit anyway. I mean, it's so, it's like every 6 months it's like something different. OpenStack, if you haven't heard of OpenStack, it is much the same as we say Linux, and what we mean under the hood is the kernel and the utilities and a lot of the times the philosophy and all of that. OpenStack is a set of interrelated projects that deliver various components for a cloud infrastructure solution. The three key ones are compute, networking, and storage. So who's familiar with KVM or virtual machine, virtual boxes, right? Any of them. That's the compute side, right? That is shared computational resources. Networking, though, and storage is something that OpenStack gives that's a little new, but the concept is much the same, right? Just like you would spin up under KVM, you would say, well, I want this system, and it's going to have this many cores, and all the other stuff, right? The how much memory it has and whatnot. But really, what you're doing is building. The computation was the first thing I think that people kind of got their heads around. OpenStack is the same. So if you want to have a store that is a block level store presented to your virtual devices, but is not stored with your virtual devices, right? And your virtual machines, I'm sorry. So, because usually when you spin up a virtual machine, when you turn it off, the storage goes away, right? So the same when the way that OpenStack gets around it is by saying you have your storage over here, you have a little bit of storage allocated to the virtual system, but most of the workload will live on this other storage over here that behind the scenes could be a SAN, or it could be SSDs, it could be all sorts of stuff, who cares, right? Go ahead.
I was going to ask,
Yeah.
do you know some examples of some big deployments using OpenStack?
Yes.
Some companies or projects what they're doing with it?
Yeah, so that's a good, that's much more exciting. We'll do this. So who uses OpenStack? CERN, all that stuff they generate when they turn on the Earth Killer thing, right? Yeah, I know, right? All that has to go somewhere, and it has to be written out very fast, right? And they cannot have latency when they are pushing all their results out to storage. So they utilize OpenStack for for the storage of their results. The others that I pulled from here, I think Purdue uses it for, and don't quote me on this, it was a brief, like making sure that I even had them down correctly. But I think they use it as part of their labs. So if you need to set up an environment, you can utilize OpenStack for that. Wikimedia Foundation uses it to store media files. Who's heard of object storage? Yeah.
S3.
S3, right? Yeah. Who's used S3 before? Okay. Yeah. So there's kind of like three types of storage, right? There's block storage, there's file storage, and then there's object storage. Object storage is where if you've ever used like a RESTful API to get an image, right? Like something out of like Flickr, if you've ever done any Flickr API stuff, it's all, or anything S3. That it means you don't really care about like where on disk the file starts or the picture starts. You just say, give me this picture and let me know when I have a picture that has been delivered. So it's we could way sidetrack into object storage, but it is different from block storage. OpenStack provides that capabilities natively. Where to get OpenStack? Did I already have that? Yeah, start openstack.org/software/start. It's free, it's open source. You can run it on one box. And I highly recommend it. It takes the idea of provisioning and makes it so easy. Like, who has ever fought with KVM and scripting out verse stuff? It is horrible, horrible, horrible. OpenStack makes it a lot easier to do.
So let's say, for example, that I have a network attached storage in my house.
Yeah.
How do I transition from, as you say, block, I mean, far less than even iSCSI or anything of that level of drill down, but okay, I want to take advantage of, how do I do it? And you know, I've got a dying NAS. I need to get rid of it. I need something that I can dedupe the 15 copies of pictures I got. Is that part of a part of this concept, or am I overstating it?
No, I don't think you're overstating it. So what you would probably do is you would mount. How do you normally mount the shared?
SMB.
SMB. Okay, so there are translators where you could present that. You would start OpenStack. The component that runs block storage is called Sender, and there's probably, I think there's a Sender SMB translator. So you would.
And these translators would live on a separate, or how separate or how homogeneous is this going to be?
So it can all be homogeneous. To get just a smidge into it, you have systems that are called your controllers and systems that are called your compute nodes. Your controllers are the things that control the components, right? It's all based on AMQP. These days, I think RabbitMQ is the messaging platform. And so you would have on your compute node a VM that has a script to run everything, right? An instance running of whatever. And then you would create a Sender instance, mount your SMB drive, and then let it go to town. What you could do is carve that up though, right? So if you want to have 16 instances, each taking a part of your SMB thing and going through and looking for copies and then writing it off somewhere else, that's where you could have the dedupe stuff into it.
Carry on.
So
Do you use OpenStack at home? You said you would recommend that we try it. What do we use it for at home? I just can't.
Yeah, sure. So if
With all the pictures.
yeah. So the thing that I would recommend looking at OpenStack at home for, or on your work computer. I say at home because I work from home. Check it out at work. Is because if you have requests coming in, if people come to you and say, I need storage, I need a VM, I need something provisioned,
Usually we need storage because all the disks are full.
it's all it is. Right, well, okay, fair enough. So assuming that there is storage somewhere that is available to allocate to people in your enterprise. But at home, it could be much the same, right? Let's say that you've got one NAS, you have a OneDrive NAS, right? Hook another one up to it.
For the sake
right?
of discussion, carry on.
Yeah, then you can use OpenStack and they'll both be presented as one device to any other systems. And OpenStack does not just have to be for virtual systems, right? You can have OpenStack engage with bare metal as well.
If you have a lab at home, it would be really, really cool.
If you have a lab at home, it's great. If you have a lab at work, it's great. Things that OpenStack that I didn't really get into, but networking, if you've ever had to fight with subnets, VLAN tagging, anything like that, OpenStack is awesome. So I would definitely recommend checking it out. It is like a whole 3 days conference that on it. Yes.
So right now, I'm actually working on owning all of my family's Dropbox. I'm moving it over to OnCloud. Right now, I
OnCloud?
just have it. Yes.
Okay,
I have it
yeah.
hosted on a VPS from DigitalOcean. Would
Yep.
OpenStack be a better? Yeah.
Oh yeah, so that's a tough question. Are you doing any processing, or are you just straight like everything's going into OwnCloud as it is?
Yes.
I don't think OpenStack would necessarily be a good solution for that.
Okay.
I think that if you looked at an object store backing OwnCloud, then that would be something. If put on my community hat, or like keep on my community hat when I say this, look at Ceph, right? You don't have to go to Red Hat and buy Ceph to use it, right? There's open source Ceph, but it is an object storage that you can use to back OwnCloud. And that may be something that will help with that. The OpenStack would be good if you're like, okay, I want to take everything and make it, all of it is going to be, JPEG at 90% quality and this, pixel size. Then you can use OpenStack to do that processing on the fly. But since you're just copying it straight up, it's probably overkill.
Okay.
Yes, is there?
Yeah, if you could help me understand, I'm a little lost in understanding the difference between a block device versus the object orientation storage, because in the end, it's all a binary value on the disk space associated to the MPI.
Yes.
So it's there or it's duplicated anywhere. From when the gentleman in the middle kind of elaborated somewhat, I understood that, hey, I can take and look at matching values and say it's duplicate. I won't duplicate it if I migrate it over to a different drive.
Mhm.
If that's so, that's somewhat valuable, but how do you understand the differential factor to what is duplicate, what is not, and where is it really becoming a functional process to utilize, say, off my NAS, or let's say I'm in my house,
Yeah.
or my small business orientation?
Sure. So you're absolutely right. When we talk about file storage, object storage, block storage, it's not quite analogous to a protocol, but it's kind of the same, right? So if you mount an NFS share, somewhere on the other side is going to be a spinning disk or an SSD, right? With a file system, ext, whatever. Butter if you're, living on the edge. But you don't have to, when you mount that share, there's protocols in place to help make sure that there's authentication, redundancy, write checks, signing off, all that stuff. So object store versus block store is kind of the same. So block store is pretty much what everybody who's ever created a file system has probably used, right? You have the device, and then it presents blocks, like 4K blocks, 8K block, whatever. Or
And the only time you know or care is when you run out of inodes.
is when you run an inode, yes. Inode 64 is the flag of the future. Right? So, like, that's what we're used to. And as a developer, when you write an application that leverages a file system, right, especially when you're writing out that, like you or your operating system has to make checks to make sure that you don't overwrite something else on the block, right? Because ideally it will be a long sequential, of course fragmentation happens, but let's say you got a brand new disk, it just writes off, right? And then it will try and pick back up and start writing again where, depending on all sorts of factors, in the most efficient way possible, but it will still try and get contiguous space. Object storage is a layer above that, right? There is still the file system underneath, okay? But there is I use the word translator, an application, whatever you want to call it, that provides an API layer to get the objects that you want, right? So when we were talking about pictures, right? Pictures have file names that change and whatever, but there is metadata inside a picture that is important that you would use to say, is this the same file? Is this the same content? The EXIF data, right? So an object application would say, give me a picture, give me its EXIF data, I will compare that. And then the underlying object application, translator, whatever, would go and grab the picture off the disk from wherever it is. Oftentimes it is chunked and stored in a distributed fashion. That's what makes object store very good, is that you can keep adding data, you can keep adding drives to the object store. You don't have to extend the file system. As a user, you don't have to extend the file system. Object store technologies like Ceph take care of that automatically. It detects there's new resources in the pool and it starts a rebalance. But you don't have to worry about like, oh, open it and as the application developer, you're just like, give me the picture, let me know when I've got it, read the exit data, and then I'm on my way. Does that help? Does that make sense?
It's a process or an API running on user level or a user agent that leverages the standard MBR ext4 partitioning system to run at more of a faster and efficient rate than actually always asking the disk level, where does this at?
Yeah, so
It's just adding another
Go ahead,
layer,
please.
right?
Yeah.
I mean, it's just putting a layer between us and the block, so we don't have to worry about that part. We're just,
The higher level layer.
right.
right, and so it's like, oh, well, why would we do that? Why would we make it slower? Is because because we have network speeds that are so fast these days. We have interconnects, we have fiber channel, we have storage fabrics, FCOE, all these different ways of getting information concurrently from multiple locations, right? So,
Cache.
well, even if it's not cache, right? Let's say that each of you knows a prime number, right? And if I say, all right, everybody give me prime numbers at once, right? Everybody shout their prime numbers out at me. Great, great. So if I can computationally handle that, then that's much faster than me going to 5 of you and saying, okay, you 5, give me all the prime numbers for this, right? So that is kind of like object storage, right? And there are other benefits to object storage from a development point of view, right? If you have somebody who never has to write file operation functions, it's a happy day, right? If they don't have to have that, we were talking about security earlier, right? If somebody who is going to get a picture, right? Let's say that it's medical information, right? And someone says, give me the scan of that, off of that MRI. And they don't have access, their application will never actually have access to the store itself, it will just have access to the API. Then there are a number of ways that you can control that. You could revoke their authentication, you could change the API address, you could disable the API entirely.
But all I can sit here and think is these folks out here never had to learn IBM OS 370 job control language to understand what it is to access block storage.
Well, and thank God.
Exactly. So your
so-
solution supersedes that by a long way.
So, sort of getting back to the 50,000-foot view of OpenStack.
Okay.
You're saying it's a collection of, like Linux is to all the GNU utilities and the kernel and everything else, it's a collection of all these pieces that are basically the cloud system or the where things are going scalability-wise for Linux. Are the bets placed on that? I mean, is that what we're calling it from now on? Is this the future? Or is this, I mean, or is this just something you really like? Or, you know, is it Red Hat's thing or just
Oh,
curious?
well, no. So Red Hat does offer OpenStack, but it is not Red Hat's thing, right? So it is a separate thing. OpenStack is its own foundation. And I would say that the things that OpenStack offers, it may not win at all adoption, right? But if you, when storage companies are providing, drivers to provide block and object storage, when Cisco is selling switches that can work with software-defined networking instead of using the proprietary Cisco, functionality. I mean, that's a good sign. 10 years from now, who knows? I don't know, but the community behind OpenStack is so strong. Did it die? Oh no, it's just me. I'm sorry. I think we're back. The community behind it's
That's in there.
yeah.
Mic transfer. Ooh, sorry, I gotta get used to the appropriate distance now. The community behind OpenStack is so strong. Every 6 months they put out a new release, and it's iterative releases, right? It's not like if you're familiar with Red Hat, where it's like 6 and then 7, and there's major changes between. Some stuff between OpenStack versions may change. Some stuff may not between their versions. It's more like if you're familiar with Fedora, right? How quickly it moves. Kind of the same thing. So I like OpenStack. I like the idea that you can have workloads dispersed between locations, have a common identity management between them, and then have, because that's what we didn't really even get into, but it does allow identity management at a project level, much like what we were talking about in the previous thing, right? So even though I have relative root access on one project, I may only have read or dev access on another, but nothing has to be redeployed, right? So I think it's very strong in that aspect.
That is good.
So that's the big stuff, right? That to me, that is like where Linux is helping drive massive worldwide resource pooling and build outs, as well as things like CERN, which is just an amazing amount of computation. Please.
Would it be fair to say that OpenStack is essentially the open source community version of the VMware suite of hypervisors?
No. VMware. So VMware is pretty much just the compute aspect of it. This is my personal, right? I don't even
They
keep
have
saying
an
this.
offering, but I can't remember what it
But,
is.
so they have like vCloud, right, or whatever. But
NSX would be just like the networking. They've got all these different components in the stack essentially. And so my understanding of what little I've looked into OpenStack so far, and I've been meaning to look more, is that, as opposed to say having a type 2 hypervisor like VirtualBox that, a lot of Linux users are familiar with different distros, that, OpenStack is your type 1 hypervisor that you would run on everything from a server to an entire data center, and the different components are somewhat equivalent to what you would see in VMware, where you have closed source commercial components for everything on the stack. And some of them are interchangeable with OpenStack, from what I understand. They can work together.
Yeah.
Part.
so there are, people are writing drivers where if you want to use Cinder, right, if you want to have block storage that is presented, you don't have to have an OpenStack deployment in order to take advantage of that. Like there are drivers where you could use ESX or whatever to mount a Cinder thing. I don't actually know if ESX supports it or not, but I wouldn't be surprised if it doesn't now, maybe in the future. I don't really know. I mean, OpenStack is not, like to me, OpenStack is the whole package, right? You don't have to use the whole package, but you don't have to try and piece stuff together. Like I feel like you have all these disparate technologies that you're trying to get to work together, right? OpenStack has a common standardized messaging backend, right? And that is, but I could see it being analogous.
It is a virtualization and, say, cloud management suite. Is that?
OpenStack?
Yeah, would that be fair to say?
Yeah. Well, but when you say virtualization, like we want to be clear, like so OpenStack started, NASA needed a way to do software-defined compute, networking, and storage. And so when you have a virtual appliance, be it something out of VirtualBox or ESX or Rev or KVM or whatever, it has all those aspects to it, right? It probably has a network address, probably has some storage, probably has some compute, but it's locked. Like you build it and that's it. You can't really change that without at least a reboot, if not a redeploy. So I feel like OpenStack is virtualization. It's like a whole new world of virtualization, right? It's like we've gotten used to the idea of like virtualizing, and the first thing you define is the number of CPUs. OpenStack is that plus everything else. I do want to get into containers because I think this might be what folks are really going to be interested in. So I'm sorry to jump, but I will be here for a while afterwards if anyone wants to talk more afterwards. So what is a container? A container is an entire runtime environment. It's an application plus its dependencies, libraries, and other binaries, and the configuration files needed to run it, bundled into one package. Who's used containers? Good. Who's those who have not heard, or those who have not used containers? I think I did it backwards, right? I was supposed to say like who's heard of containers first? Is that right? Who's heard of it but not used it? Okay. So containers, this diagram, can y'all read this up here? Any of that? No? I'm gonna make it bigger. Nope, that's not good for me. This is important. I want to make sure that we can see this aspect of it. Maybe? Shoot. I don't want you. I didn't do anything, did it?
There's a slider in the bottom corner.
I can't quite. Oh, I can see it over. Nope, can't see it over there either. Let me grab this. Boy, computers. They're so awful. There's my desktop. Oh, golly. What is going on?
Are you trying to maximize?
Yeah, well, I'm trying to get where we can read this. That's what I'm trying to get to is the zoom. There it is over here. All right. So this is, can y'all see, is this coming into focus over here yet? Yay. All right. So this is your traditional, what you would get with any sort of virtualization, right? You've traditional virtualization. You have your hardware. It could be hardware. It could be another virtual machine. It could be in the cloud. It could be whatever. Then you've got a Linux kernel running on it, and then hypervisor technology that is providing the translation. Oftentimes, this is on CPU and then drivers within your devices. And then when you want to get new instances of these applications, right, you start up a whole new stack. Virtual machine A is, for anyone on the virtual machine, it's a whole entire stack. It has its own kernel, it has its own networking, it's got its own user space, it's got everything, and then there's an application right on top of it. And that's all you need is just that little application, but you have to start this whole virtual machine to get it. Same over here, and here, and here, and here. And so it takes time to start. It takes resources to start. It takes management, right? Security, you want to patch them. It takes all these extra things to make sure that you can just run application A separately from application B. And this, in a way, is like saying that OpenStack does not solve all the problems, right? Because when we were talking about compute before, we were saying, oh, you'll start an instance, that's a virtual machine. So this is somewhere where, depending on your workload, you may find OpenStack is not advantageous out of the box, but containers could be. Containers, however, when you have a, sorry, if anybody has the same ThinkPads as I do, the like mouse pad is just like awful. Here we have hardware, we have the kernel, and then we have a container host. This is akin to the hypervisor before. So then we have a container and it's running application A, and that's all it's doing. Application B, and that's all it's doing. Application C, and that's all it's doing. It does not have to have an entirely new kernel running on it. It doesn't have to have new drivers running. It doesn't have to have anything, right? It says, I will have inside of my container only what I need. Everything else will be inherited from further down the stack. Very quick to stand up, very quick to scale. Startup time is like your application starting, not your entire operating system starting. So now that we've seen that, let me go back to, so I can go. Okay, so virtual machines provide an entire system. The hardware, the kernel, the operating system, applications. Containers rely on the underlying container host to provide everything except what is needed to run the application in the container. So applications running in containers will be available and providing services faster than if you have to spin up entire virtual machines. So there's a speed improvement both in starting the container and its operation. You don't need to have another kernel, you don't have another abstracted hardware, and then you can also rapidly provision it and kill it, right? Who's heard of like pets versus cattle? A few people?
Herding cats versus herding.
No, like, all right, so you have a cat, right, or a dog, a pet, and if it gets sick, you take care of it, you take it to the vet, you love on it, it has a name. If you ever heard of cattle and one gets sick, you have steak. So, like, virtual machine, or not steak, sorry, if there's vegetarians in the room.
Don't eat sick meat, that's it.
Well, let's say that it breaks its leg. Sorry. I'm not a farmer. We don't want
Spongiform encephalitis.
We don't want that, right? If your cat breaks its leg, you take it to the vet. If one of your herd breaks its leg,
You grind it up and feed it to the other cows.
just like containers. Yes, exactly. But yeah, VMs are your pets, right? You give it a name. You want to make sure that it stays healthy. You got to patch it. You got to take care of it. People rely on it. If a virtual machine goes down, you're going to get a call. If a container goes down, then the container hosts make sure that nobody gives a shit, right? Like, who cares? Because, sorry.
You're going to get a call.
You'll get it. Well, so that's the whole thing, is that like in a well-deployed system, right? Like, what are the thing?
You just hit the magic word.
What?
Well deployed.
Okay, well deployed. But that's the thing. Okay, I will take a step back and say that everything that we're talking about today is a perfect world where network cards don't fail, cables are well patched.
Let us know when you find them.
Yeah, exactly. In a virtual machine. It's great. But yeah, so, however, if things do go sideways, then your, Puppet or Ansible or whatever you're using, because God help us if you're doing things manually without any sort of automation these days, right? Will recover gracefully. Right? I mean, and that's kind of the whole idea, is that what is your time to recovery? Like, what does it take to get back to your SOE? You know, these are things that maybe it may not be important for everybody, right? It's kind of like the System D conversation. Does everybody need it? No.
Wesley, let me
But
mess with
They
you.
have a choice.
Yeah, well, I mean, CentOS 6 is going to be developed for another like 10 years, so.
Oh, God.
You know, what I think the reaction we got here was
Yeah.
that we all work in a real environment, and we all know that it's just a different circus, but it's the same clowns.
That's fair enough. But if you can protect users from themselves, then, you know, we've made progress. Two types of containers. Before I worked at Red Hat, I was a developer. Before that, I was an admin at a home health company in South Mississippi, where it was like they had not seen computers before they went to work. So I'm not like, oh God, everything's perfect in all data centers everywhere. Far from. Just slight cred, I guess. Cleaning out a closet post-Katrina was like the worst thing. That was a long recovery period, for sure. All right, so there's two types of containers. There's host-based and image-based. Host-based is what most people are familiar with. Everything, when you run application A, B, and C, they're all going to use the same kernel. They're all going to use the same drivers. That's kind of the traditional container world. However, there are image-based containers as well. So let's say that you want to test application A with Python 2.4, 2.7, and 3, right? You can have the same kernel, right? So you have an x86, and then in runtime A, you have one version of Python, B has another, C has a third. You can run your application concurrently and run tests against it without having to spin up anything new. The Python binary and related libraries all live inside the image container, we'll say the image-based container. So you can have your choice. Because some people, like originally people were like, well, what's the good part? The good part about containers is I have to have VMs for all my different environments anyway. You can use image-based containers to build out just enough of your environment, and then you can still have all the things that are similar running underneath. So where do you get containers? Docker. Who's heard of Docker? More people have heard of Docker than I think more people have heard of containers. So Docker is container. That was like a very brief thing. Yes, please.
What's new in OpenBZ?
I don't know. What is that? Help me.
Containers. It's been around for like. No? Yeah.
OpenBZ. Why? Tell me why do I know that? But I can't.
It's a broken. It predates a lot of the other container stuff.
Yeah. Okay. So is it like old LXC kind of stuff?
It
When-
predates LXC. Pre-LXC.
Darn. So what's new in it? I don't know.
I mean, Docker
No.
is just a good UI. Like, nobody's heard of LXC.
Well,
Who's heard of LXC?
Yeah. Okay. LXC. Some people have heard of LXC. chroot. If anyone's used the chroot environment, SE Linux. Those are all old container things that we were using before they were called containers.
SE Linux is not a container.
SE Linux is a
Labeling system, not a container.
SE Linux will keep your kernel from executing. It creates environments where, depending on the boundaries, you will either have execution or not.
It's one
Your
environment.
boundaries exist because of your labels.
It's a mandatory access
It's
control.
labeling, and we still have chroot and it's same installed Linux.
I think we can pen this discussion for later.
So,
Just trust us, SE Linux is not a container.
so Docker is
It'd be easier.
okay. So it is when we would go into places. When I would go to see a customer and say, they would say, "Oh God, containers! I have no idea what a container is." We would say, like, "Well, you have been using things that are either built into or similar to containers for a while." Docker, what does it do? Docker did make it easy to manage containers in a way that was kind of the whole infrastructure, right? So you can use Docker to build your container. It is a specification for containers, because before that it was kind of like back when there was KVM and Zen and all the others. Right now, it's pretty much one interoperable virtual Docker. The Open Containers Initiative, their format has been pretty much adopted to it. It's also the platform, but it's also, I don't think I put it, no. It is the whole, like, how do you keep your containers sane? So if people are like, well, I'm not gonna run containers because I don't trust where it came from, then you can use the Docker registry to like sign, and within an organization you can have everything that is trusted. So the reason that it's... I heard that. I'm glad you joined us. So who uses Docker? These are some examples of folks that use Docker. If you want to go check them out, download it from docker.io. I think containers are more things that people who are providing development environments on demand are going to be more interested in, right? So if you have, yeah, please.
Oh, it's just a question about the Docker idea. Wouldn't they still have security? I mean, if they're built on old libraries and things like that, and they're all contained in one, wouldn't we still have a lot of vulnerabilities and problems? You were saying it's sort of to eliminate some security concerns, you could have this idea of this container where everything is built into one segment and it's all patched and pushed together in one piece. Aren't there still going to be problems because they're built on old libraries? You have to update all the pieces together and so on.
Yeah, so it's a good point. All right, so y'all remember this one? So here I've got one kernel, two kernels, three kernels, four kernels, and different workloads on all of them. So if I want to patch it, I have to make sure that 4 systems and 4 groups of people are happy, and I've got my maintenance window set up, and everybody can agree that this is when we're going to have a patch cycle. Right here, it's just one environment has to be patched. Now the users.
That assumes
Whatever.
that all 4 of those, or the layers on top of that, all play nice with the underlying piece.
Yeah, sure. Yeah. No, well, I mean, yeah. This doesn't solve the people problem.
It never will. And now your patching takes on 4 hosts.
I'm sorry, say again?
And now patching the kernel takes on 4 hosts.
Take on.
Never mind.
I'm sorry. Tell me later, please. Sorry.
Okay, if I understand your question correctly, typically like an entire application isn't in a single container, a single process is in a container. And version control is very easy. So but in terms of going back on containers, so Docker does make it very easy to just pick out a particular container and how to, what may be a stack. I mean, they outfit a picture of like a shipping, boat with, intermodal containers stacked on top of each other, which may function as an application. And you might be able to they basically work with each other through APIs, kind of like the Lego.
That all is how the sales brochure works very nicely.
Okay, that's how.
When it comes to the real world, all hell breaks loose.
Yeah. So you do have to be very careful with containers that you have everybody using the same images, right? Version control is important. Docker does, that's one of the things, right? What does Docker do? Like Docker is the whole thing, right? So that's how that's managed in a way. But you don't have to do it all yourself, right? Some people use like Jenkins to, build the containers, right? You don't have to use Docker to do all of that stuff. So you were saying something about like how do things get deployed?
In almost every Docker image I've ever seen, the first thing that happens is it upgrades all the libraries. So like it does, if like shell shock, you would be vulnerable in your Docker image, right?
Yeah, if bash is included in the container image, yeah, you would be definitely.
But you don't have to patch the kernel. The kernel's on right.
Well, you hardly ever have to patch
But if you
Well, yeah, you should be patching the kernel essentially.
But if you have like 4 containers, that's one of the things. Like if you have 4 processes on a single VM, then you need to patch bash once for that VM. If you have 6 containers that all have bash included, then hopefully you patch it once and then your CI all rolls and it gets deployed, and that's great if you have that all set up. But like it may be the case that you have 6 different containers, and you have to patch bash in each one of those 6
Yeah.
containers.
Well, that's true. So let's say you support developers who want to develop on 3 versions of Python and 4 versions of whatever else they've got, right? Ruby and all these things, and then you're patching you're building new gold ISOs anyway, right? For your images. It's not, none of these are like magic bullets, right?
A world with containers is better than a world without. I was just wondering about the patching thing.
Well, so that's akin to the cattle being with a broken leg, right? You don't, a lot of times, like, well, okay, I'll say that when you patch containers for security issues, it is a little like taking a step backwards and converting them into virtual machines, right? Like into that same model. Instead, it's better to patch your original instead of patching a running container, like kill that and then patch your original and then spin up a new instance.
We got 2. So I think first and then second.
Well, I mean, especially when I hear people that come from like a developer background talk, one of the reasons they like or want containers is that they can control the version that they know is compatible and doesn't break their app. So if you have multiple different apps, you could just be completely making a wider attack surface because you might have to support 5 different versions of Python and 6 different versions of this or 7 different versions of that to keep everything running. And I mean, obviously, this is a lot of this seems to be being pushed by developers anyway. So I don't think we're really looking at this as to increase security, but to alleviate their own headaches of building an app and keeping it running efficiently without breaking something else. So I just see it making more problems, really, especially short term. Maybe sometime long term that's figured out. But
Yeah, I don't think you're wrong in that aspect. It's a growing pains moment for sure.
Forgive my ignorance, but on a commercial level, is something like Google App Engine a concept of containers?
If I Google App Engine being, I don't think I know what that is. I have a guess, but go further.
Google has an initiative that you buy a thing, and one thing you can get is virtual machines where you're controlling the whole stack on a virtual image and includes. But apart from that, they have App Engine, which essentially gives you like a PHP environment or a Python environment.
Yes. Yeah.
And you just write your app to that, and you're not managing any of the underlying server. Is that an example of containerization on a commercial level?
Analogous to
It's definitely analogous to it. So what Docker would enable you to do is provide that internally inside of your own environment.
Okay.
So I have 3 statements. One is that to his question, yes, you're absolutely right today, but you could implement security into containers as well. And so therefore you can secure your container up to your standards and then deploy those. So it can actually be a faster way to patch or do whatever. So it doesn't have to be a negative thing. I believe that Google App Engine is more of a cloud infrastructure instead of a container, just to be clear. And finally, the pets versus cattle argument is not just because you only brought it up on containers, but you can do that same thing in the cloud. So it's not that's really more about maintenance. It's about like, you don't want to have that box, you don't want to patch that box, just kill it and bring up another one. That's one of the philosophy.
So I haven't ever met him, but I'm guessing. Is this Dagmar?
Yeah.
Yes, great. Okay, good.
Dagmar, Wesley Dagmar.
If you're getting the feeling that I'm not a fan of containers, you would be correct.
That's totally fine. I realized I sounded like a bit of a prick earlier when I was like, I'm glad you joined. I am glad that you joined us because I think a lot of people are here to talk about System D as well. We're happy to talk about the warm fuzzies with clouds and containers, but I think the original purpose of this was to talk about System D, right?
It's not containers specifically that our problem with. It's what they're going to be used for and what they are being used for. Because what I'm seeing for overwhelmingly is folks that don't know what they're doing and they want to run DirtPress 6.7. And it comes with these dependencies, and the people that are making DirtPress 6.7 say, here's this container, you can use it. It has all these dependencies in it. They'll never update those dependencies. That's going to be frozen in time forever. And they're probably not going to go and get patches from the guys who released DirtPress 6.0. So as an admin, you're trying to run the system, and you've been doing all of your stuff. You've been following your procedures and your policies. You've been getting your patch windows done, and users need that patch window discipline that the virtual machine environment generally requires, where you say, April 21st, your application will be compatible with PHP 5, or good luck, because they won't ever patch. And if you're an admin and you're administrating an environment with multiple users on it, and they're running a bunch of container stuff, you've got 9 different versions of PHP, and 9 different versions of all these little libraries, and 25 different versions of all these other little things, because all these users go, well, we don't want to break our app, so we won't touch anything in it. And that is a nightmare scenario as a sysadmin standpoint. You're going to be getting just the network security group's going to bring you your email to tell you about the vulnerability triggers in a large box full of DVDs.
Yeah. So one thing to be sure is that whether you're rolling Docker, something that is the Google Apps thing, there are a lot of different ways to deploy containers. None of that means that your users get anything more necessarily, right? You don't have to give them.
Let's be honest here, okay? Let's be completely honest here. Any one of us in this room can sit here and screw up a perfectly good application in any one of these formats, be they hypervisor, container, Docker, bare metal. We can all do it wrong.
So we started about 15 minutes late, so I saw the board starting to come in. If we can wait, we're gonna run about 10 minutes longer, if that's okay. And do we want to end it out on System D and talk about System D?
Yeah, I think that's totally good. Yeah, definitely.
I can sum up this thing on again. You keep switching it off. Why do you do that? So my problem with System D comes back to one very key point that I remember seeing on Google Plus, Mr. Leonard Pottering. By the way, the Red Hat rep that came to see me at the office 2 years ago was not able to promise me 5 minutes in a room alone with him. And he was saying, oh, we can get you anything you want for a Red Hat conference. I said, 5 minutes alone in a room with Leonard. He went, what? But Leonard had this nice and long post. It was, it was a wall of text talking about how, well, we do this, and then we do this to upgrade init, and then we have to do this, but then we have to remount the root file system, and that causes a major problem. Well, he basically described this giant circuitous thing where he literally painted himself into a corner, and this is our fundamental problem with all the old school admins that don't like System D, because you're doing all this stuff so that you don't have to, well, you're doing all this stuff, and at one point he winds up, you have to unmount the root file system and bring it back in, and that's the problem. Well, when we had a teeny little init with maybe 400 or 500 lines of source code, we never patched that. It didn't need patching ever, and it's just getting larger and larger and larger and larger. That's our main problem there. We had a nice tiny little init. We never had to screw with it. Most of us probably we'd go entire distribution releases, never see it patched once, because it didn't do anything except for, kick some other apps off. We didn't have to worry about whether you had to remount root file system or do this terrifying thing with initRD or any fancy stuff. It was all simple. And Leonard seems to chronically not notice when he's painting himself in a corner and go, well, what I need is a helicopter to get me out of this little room.
So how many here know what System D is? How many don't know what System D is? Okay, I'm not a really good describer of this. I was just kind of made aware of it.
Monolithic.
What's that?
It's a monolithic init.
Right. So back in the old days, how Unix has always started has been this series of bootstraps, right? Pieces built on top of each other that called pieces and so on. And so now, to fix some problems that some people don't think are real problems and some people do, there's this big argument in the community and even some forks of Linux about how we're going to have the new startup environment. Systemd is going to take care of logging levels and various other functions, and a lot of people have a problem with it because it's like a black box. We can't see what's inside the box, right? That's essentially what people are sysadmins are frustrated with. And then the other side of that is it allows some good things too, like logging outside of containers. That was a big problem before. Sending messages back down the CH-rooted environment or whatever, trying to get it outside.
What the problem?
Well, some people disagree, right? So there are pros and cons about this, and the community is really split. So that was kind of going to be part of the discussion too. And that's sort of what systemd is. It's how the system is going to be started up in the future. And then the on top of interesting thing about this is that the large companies that are driven by the enterprise, for instance, Red Hat, is backing the systemd side. And so the future of Linux, if they want to stay in line with where the money is, where manufacturers are paying, they're going to go with the systemd environment. And all the sysadmins who are against it are kind of frustrated because they feel like their choice has been taken away from them. It hasn't, but if they want to stay with where the money goes, they're going to have to learn it. And so that's the
How is that
contention.
different from not having a choice taken away?
Well,
You can have the money, or you can have the choice.
you can afford Linux, right? It's open source. You can do whatever you want. But if you don't want to buy if you don't want to use that application that your company wants to use, or your company wants to use a certain application and it's only going to run on systemd environment, yeah, you're going to have to learn it. You're right.
Something weird there. Or at least until systemd goes and absorbs the kernel.
So
I think both sides make valid points.
Taking
Let's be
over
honest about
DHCP
this, okay?
functions now. What the hell?
Let's face it, we've come from, as Groucho Marx so succinctly said it, we come from nothing to a state of extreme poverty.
So, are there any questions about systemd? Does anybody have any comments on it or experience with it in the field that they want to talk about? Because that was something that originally, when I was the one that proposed the idea for this panel, and I was at DragonCon with Mr. Scott Jones there, and we had this really packed room, this big discussion about it, because there were a lot of people, developers are very much for it, I think, but a lot of sysadmins are very much against. It's kind of brought out a lot of old
And
loyalties.
who's responsible for keeping the system running of that two groups of people?
It's a philosophy thing, right?
When they wrote all the code that runs the entire OS, it is a different.
It'd still be a dumb question from somebody who knows, I still don't know what systemd is.
There are
but-
no stupid questions, just stupid people.
You just said systemd developers like it, sysadmins don't. What about a systemd for developers and system S for sysadmins and maybe the point you don't need?
I mean, so at some point, you do have to have something that starts the computer.
We had something.
Well, so we did, and I
Those
don't
wire
disagree.
breadboards just got to be a real pain in the butt, you know what?
Yeah, I feel like the systemd conversation has fractured into three conversations. Like, there's the personality behind systemd, which is an interesting conversation because I don't think anything else except for, Jobs, Gates, Ballmer, and Torvalds, right?
Yeah.
Well, and let's not forget Solomon. But like for, personalities, like, who cares, right? I think that in a community that is built on electronic communication, it is important to have decorum, and sometimes I think Pottering doesn't, right? He doesn't know what to say in a way that will make any points understandable over email, right? So that's one thing, is that people read this stuff and they're like, oh my God, what the hell is this? And we're gonna replace our entire infrastructure by something written by a kid, right? That's fair. I think that's a valid criticism, because in this community, we do communicate over email, and there is importance in, if you're gonna try and pitch an idea, for the most part, you should be able to speak about it and not piss people off. But two, the idea that we've been doing it the same way forever. And that is the one, well, and then three is systemd has gotten too big, right? I don't disagree with that either. I think that this idea that we can fold everything into systemd and hope for the best is going to be problematic. Yeah. But I think the biggest issue with systemd is that it changes what we've been doing forever and ever and ever and ever in the Unix environments. And
Linux only goes back to 1970. That's not forever.
that's pre-epoch. There was no time before 1970. So And I don't know that System D is the be-all for that, but we needed something that could handle I think that we need a init process that was not so serialized, that you didn't have to put things into FS tab so you didn't block on boot because networking wasn't available, right?
Yeah,
And so,
but now we've got this one piece that's becoming larger and larger, which is essentially a mono.
but that's part three. That's part three, right? I think that what System D has done, and I'm not going to defend the code.
yeah.
I'm not going to defend
They'll boot faster.
Well, no, not even. I don't. Who cares about booting faster? I want something that is not just going to be for a piece of big iron, right? I want an init that is flexible enough, and I'm not saying System D is it, but I want something that is flexible enough to boot on, microwaves and refrigerators and space stations and satellites and desktops and Mars rovers that will not have to boot serially on a premise that was decided 60, 70 years ago. It's not like, and I think that, I'm not saying that we should throw everything out. I think that System D started a conversation that we had a sacred cow in the init program that we had not been willing to address. And my worry is that the critiques of System D are getting lost because they're saying, well, it changes things. Well,
Excuse
Well,
me.
yeah.
well, no, we've given the same specific reasons why we don't like it over and over, and they've been ignored over and over, so we just get tired of saying it.
Well,
Normally, when we do develop, we have these tiny little pieces that you can swap out at will. Somebody comes up with a new one, we run it for a while, some people run it, some people don't. Eventually, we wind up discarding the parts that no one likes, and we just get the good stuff out of it, but we don't get to do that with System D.
Well, we're going to get to do it with anything.
Deal,
Init is
we're
a
always
nit.
stuck with the binary logs, which they're just a disaster waiting to happen for some folks. And we're stuck with the fact that it's all one piece. So any updates that need to be changed to System D affect all of this as part of the system. Instead of being able to just pop this one little piece out and replace it without even making the system hiccup, now it's attached to all these other things and they all have to temporarily go down as well. That's
So-
not making us happy at all.
I think,
So we had I'm sorry, I just wanted to make sure we got a question.
Well, I think you started to cover things. I just wanted to remind everybody that one of the points of System D was to move from a state transition machine to a dependency graph, but you already talked about serialization. But
And Upstart was really doing great work
yeah,
on
then
that.
Upstart was and so System D replaced Upstart. So you kind of get back to an architectural situation where it's really a question of architecture, and it's that issue. It's not necessarily. I mean, it could be anything. It could be anything anywhere, and it gets to be a broader question of whether Red Hat is being a good steward of Linux or not.
It goes beyond Red Hat in that regard.
Yeah.
I think your points are very well taken, all right? And again, I think there's a case to be made for the modular piece-by-piece environment with which we are familiar, and you will admit, familiarity breeds contempt and/or comfort, either one, okay? And
in this
likewise,
case-
there's a need for, shall we say, parallelization as well as, are we parallelizing or paralyzing? It's your choice.
So we need to wrap up in the next couple minutes, so just maybe one more question.
Okay, so I've been studying the DevOps approach and culture lately. You start with a minimum viable product, and then Dev and Ops collaborate better with each other through continuous development of something that works. And kind of with this online writing lately, hearing the dispute between developer wants this and Ops wants this. It sounds like what you have is a minimum viable product that maybe improve collaboration to help fix something. Maybe the System D 2.0 would be.
Maybe that ultimately there'll be that compromise, and that's what we'll go.
Or maybe we'll just wait until System D gets its own modular dependency system.
That would be good.
So any other thoughts, guys?
thanks
Thanks so much. Thanks, Wesley. I don't think we introduced ourselves, but Wesley he's part of INLUG. Howard is part of INLUG. I go to INLUG. I think you're on the mailing list. So the Nashville Linux Users Group, if any of you are interested in Linux and live in the Nashville area, come check it out. There's a lot of good information that gets passed
Clearly,
there.
you start showing up more. It's becoming acceptable.
It's a Tuesday. If you're local, Tuesday night, Vanderbilt's MRB3 big room. 12:20, 6 p.m.
Second Tuesday of each month.
Second Tuesday of each month, and this is the thing. Yes.
All right,
Thank you.
thanks, guys.